Programmable Logic Controller, the brainpower behind industrial automation. Welcome to the world of industrial automation. Let's explore the critical component that powers countless factories, processes, and systems around the globe, the Programmable Logic Controller, or PLC. Imagine a brain specifically designed to control machinery. That's essentially what a PLC is. It's a ruggedized, digital computer built to withstand the harsh environments often found in industrial settings. Think extreme temperatures, electrical noise, and vibrations. A PLC can handle it all. Now, what makes a PLC so special? It excels at taking in information from the real world through sensors. These sensors could be monitoring anything from temperature and pressure to the position of a robotic arm. The PLC then processes this information based on the logic programmed into it. Let's say a sensor detects a conveyor belt is moving too fast. The PLC, following its programmed instructions, might then send a signal to a motor to slow the belt down. This constant cycle of input, processing, and output allows for precise and automated control of complex processes. In the past, industrial control relied heavily on relays and timers, hardwired components that were inflexible and difficult to modify. PLCs revolutionized this landscape. Their programs are easily reconfigured, making them adaptable to changing production needs. Need to adjust the speed of a bottling line? Simply modify the PLC program, no rewiring required. PLCs are the backbone of modern industrial automation. They're used in a vast array of applications, from controlling simple machines like pumps and motors to managing entire production lines in industries like automotive, pharmaceuticals, and food processing. Let's break down the key components of a typical PLC system. CPU, the central processing unit, the brain of the PLC, executes the program logic. Input-output I/O modules, these are the interfaces that connect the PLC to the real world, receiving signals from sensors and sending commands to actuators. Power supply provides the necessary power to the PLC and its components. Programming device, this is used to create, download, and modify the PLC program. Programming a PLC involves using specialized languages like ladder logic or structured text to define the control logic. These languages are designed to be intuitive for engineers and technicians familiar with industrial processes. The impact of PLCs on industry has been profound. They've increased efficiency, improved safety, and enabled more sophisticated automation than ever before. As technology continues to advance, PLCs are becoming even more powerful and versatile, incorporating features like advanced communication protocols and integrated safety functions. The world of industrial automation is constantly evolving, and the PLC remains at its core. Understanding how these powerful controllers work is essential for anyone involved in modern manufacturing and process control.